I have this 12 volt 2 ampere charger, nominal output 12.28. I want to take 14 volt, minimum 14 to 15 volt. There is one condition that we can purchase new one, but I will modify this one to fulfill our requirements. Let's start. If you don't have good experience in electronics, never try to repair, because here are live voltage. Take care for the safety. Never touch any component in this power supply, even the circuit is connected to power supply or removed from power supply, until we verify voltage on this capacitor, smoothing capacitor. If there are voltage, discharge it, then start work. Assalamu alaikum wa rahmatullahi wa barakatuh. I am your host Muhammad Ashraf and I welcome you on my YouTube channel. Let's modify it. If you have not subscribed my channel until now, subscribe it. If you want to watch my videos in future, you can press bell notification for all. We have 12 volt, it is safe. First I will explain the modification process. We will see what will the effect on this charger efficiency. If we can compromise on that efficiency, then we can modify it. Otherwise, the best option to purchase new one. Line neutral, 220 volt. Bridge rectifier. After safety, bridge rectifier. After bridge rectifier, we have 310 volt DC in case of 220. Then these voltage are reaching to this MOSFET. Here is IC. I connected a transistor for best understanding. It is driving this transformer. This negative side is connected here. This transformer is providing output. We have output rectifier here. It is providing DC output voltage on this capacitor, and then we have some inductor or like that, and we have output. Portion of this output from this point, positive point, is provided to voltage divider network. Two resistors connected in series. This center point, it is connected to TL431 Zener reference. It will reach to pin number 1, pin 2 grounded, pin number 3 cathode pin. That is connected to optocoupler, LED side. It will provide feedback to this PWM controller. When we receive our required level, voltage level, that time at 2.5 volt at this pin, we need 12 volt. When voltage divider network will provide 2.5 volt here, this high resistor, this low resistor, when 2.5 volt, this TL431 reference regulator will provide current to this LED. It will provide signal to this transistor and it will intimate the IC that required voltage level is obtained. So it will control its duty cycle. Now we need to change this resistor. When we are changing it, what will happen? Let's suppose this IC is working at 50 kilohertz. Just for example, when line voltage are 310 volts, no load, that time out of this cycle, that is one cycle, it will use just only this portion. I can say 5%. 5% on time, 95% off time. Same next cycle, 5% on, 95% off. So it will maintain this switching. If input voltage will decrease, voltage level will decrease here, it will increase its switching time, allow more current to build more magnetic field here, so that output voltage will be regulated. Same way, we can say 1 ampere load is connected here. That time the voltage will drop. This level will drop, then 12 volt, voltage level will drop here. It will decrease the current in the LED, so it will give signal to the PWM controller to increase switching. Duty cycle, we can say in both cases, it will increase duty cycle. Let's suppose 20%. 80% off, 20% on. This IC can adjust its duty cycle from 0% to 97%. This is its normal working condition. But if we will increase the output level, we will force this IC to switch more than its allowed limit with this voltage level, so that we will receive more voltage. We are opening this shutter more than the regular operation. What will happen? If it is switching with no load 5% and we are forcing it to switch, let's suppose after modification we want 10% with no load at regular input voltage. Now the IC will switch at 10%, remaining we have 90%. So we decreased its efficiency by increasing the output voltage, because P out is equal to V out into I out. Output power is equal to output voltage by output current. Normally if the voltage were 12 volt 2 ampere, it was 24 watt. If we will increase voltage to 15 volts, now the current will decrease. 24 divided by 15, the current will become 1.6 ampere. Because output power will remain same. There is an option to increase the current, but I will never recommend to change the current, because when we will change the current from its current sense resistor, we will damage this power supply. We will force PWM controller to deliver more current that may damage MOSFET, or it will degrade the transformer. Transformer will heat up and it will damage very soon. We can increase the voltage level. In that case, the current level will decrease, but we will not increase the current. So let's see this resistor, and we will change this resistor now. It is connected at output terminal. This output capacitor positive terminal, and here is optocoupler. These 3 points are for reference regulator. This one, IC1, reference anode cathode, pin 1, 2, 3. We will check pin number 1, reference pin. Reference pin is this one. If we see, this resistor is connected at positive terminal, and the second resistor 2491, it is connected at negative terminal. So this is our required resistor 9761, 9760 ohm, and this one is 2491, 2490 ohm. The same ratio. If 12 volt, 10k resistor this, 2.5k this. At 12 volt, this resistor will provide 2.5 volt. Now, we will increase this resistor from 10k to 12k. So we will receive approximately 15 volt. Because it is in charger circuit, So output capacitor is charging, resistance is increasing slowly. This is 2491. Two 2.6, 10. I will connect these resistors in series. If we have SMD resistor, that is the best option. Otherwise, we can use regular resistor. Let's check it. Yes, we have 15 volts. That's great. So this is a result of this modification. I replaced this resistor with 12.6K. 12.6K and this one 2.5K. So it is 15. 12.6 plus 2.5, it is 15. So we have 15 volt. If you enjoyed this process, give a thumb up. If you have any question, please write in the comments. Thanks for watching.